next topic for today is GUI applications, or in other words, Java graphical frameworks. And I will tell you about design and little history of Java graphical frameworks, which are part and built in standard Java, which is AWT and Swing, some of main principles for creating graphical user interfaces or GUI, layout manager, model view controller architecture, events, event handlers and listeners, and some other Java frameworks which are not part of standard Java. I will just mention them for you to know, like JavaFX and SWT. And Java supported development of graphical applications from version 1, and this framework was called AWT from Abstract Windowing Toolkit. What you need to know about it is that almost nobody uses that, and almost nobody uses that because it was slow. It worked differently on different operating systems, and therefore it is not used anymore. And starting from Java 2, and remember, around that time, new Java version was released approximately after each 2 years. Different graphical framework was built into Java, which is called Swing. And Swing shouldn't be written in all capital letters, in difference with AWT, because AWT is abbreviation, but Swing is just code name. And for some backward compatibility and maybe other decisions, they decided that Swing will extend AWT. So that means AWT is still, these classes are still into Java, but they are not used directly because Swing classes extends AWT, and we use an override all of these methods, etc. And we may use Swing, and of course indirectly we use also AWT, but we do not count them. And important part for this was that it looked similarly in all operating systems, and it introduced model view controller approach in design of these graphical applications. And this is also part of standard Java. It's built on top of AWT. It doesn't rely on platform's native components so much than AWT, and it introduced this model view controller design, and I told you about this also yesterday when Spring Web Framework introduced model view controller approach. But initially, of course, it was introduced in graphical applications, and here it is much more clear than for web applications, because you see quite distinctively 3 different parts of your application if it is complicated enough. So one part which describes what user see on screen, that is view part. Depending on actual framework you are using, it may be some kind of template files like XML, maybe also built dynamically using Java methods, but it describes what user sees. Then there is model part. I think it's coming from business model, but in general this means that these are your structured business data which you store to handle particular process what you want to handle with this application. And then there is model controller part which connects view and model in such way that user does something in view, like press add button to some row. Controller intercepts this event and create new object inside this model part, like new customer or new order or whatever, or change something. Then these changes are then handled by controller, and in view part you see new entry created for this particularly created object. So initiative almost always comes from user, what it does inside the graphical interface, but when it is handled, then this data model is updated, and data models of course influences how this particular graphical interface, this view part, looks like. And here are packages, how these are put. AWT is in Java AWT, and Swing is put into JavaX.Swing, and some part also in accessibility. And this is how Swing application looks in default mode in different operating systems on different platforms. And what are important elements for these graphical user interface classes? First, there are different kind of containers, and containers, if you look from Java perspective, they contain other Java objects. If you look from user interface perspective, these are some rectangles seen on screen, and inside these rectangles there are something else. Of course, in some non-standard situations this may be something else, some rectangles, like you may decide to make your buttons like circles, but in general these are areas which contains something inside them. And main object which contains everything else is GFrame, and GFrame is like windows together with title bar, with these buttons and with resizable border if it has resizable border. And then JPanel or GPanel is a part inside this GFrame, like let's say what you see here in this presentation. And then there are different components which you put in containers. These are buttons, text fields, lists, combo boxes, etc. All these are named JButton, JTextField, J blah blah blah. And then there are so-called helper classes, which actually are structured properties, because according to the object-oriented approach, every time you have complicated property of something, like color is, for example, sum of either 3 different colors or 4 different colors. It may be opaque or transparent, and there may be some shadings, and this color may be gradient and with some patterns inside it, etc. So color is complicated property, font is complicated property. It consists of font family, font name, bold, italic, underline, overstriken, etc. etc. So all these complicated properties are Java classes, which describes all these complicated properties of these containers and components. And when you create some kind of graphical interface component like button, you need to describe its properties. You need to describe what kind of methods will be you using and what kind of events it will produce and how it will be handled. And if you do everything dynamically in Java, you first create it using constructor in most of cases. There may be cases when you use this factory design, name of class and static method, something like get it, create it or whatever. Then you configure it using its properties like set text for it, and then you add it to some container where it will be located inside, and then you need to say what kind of events it will produce and how you will handle it. And this event handling is very similar to exception handling. So when you create some kind of event, it is yet another Java object, but these events are assigned to these listeners, which will subscribe to these events and will listen to these events. And when you press this button or enter something and click somewhere, etc., then such event object is created and it is provided to these subscribers or these listeners, which listen to this object and does something according what you have put in their body to do with this particular event. And so this approach is part of this model view controller design, and it is like event-driven development. So you create different kind of events, and then these events are handled depending on how exactly you describe it for these events to be handled. And here is pseudo class diagram on the right, which is a wrong class diagram, because in general here you should see diamond and this end, nothing else here. So JFrame contains JPanel, which contains JButton and JLabel, and this is how it may look in graphical interface. And usually when you build these graphical interfaces, you start bottom up, because if your system will be busy, under heavy load, etc., if you will start top down, user in some cases may see that you add some new element in default place, which is top left corner of this container, and then it is resized, then it is moved, etc. So therefore you first create all needed objects, then you added them into container, and then sometimes you even all before that your container might be hidden, and you show it up only when everything is prepared and ready. And here are excerpts of Java code, how exactly you can create all these elements, but we will not go into much of details here because we will use a framework which has code generator for us, so we will not need to know everything in our head, in our memory. And so when you create this JFrame, here are these internal properties of this JFrame. It has some other panes inside it, but again, if we have code generator which generates proper code depending on graphical design what we create, we don't need to know so many details about it. What is a little bit more manual work to do is about layouts. In difference with some other graphical frameworks and programming languages what I have used, like Visual Basic in Microsoft Windows, Java was all the time supported by many different platforms, and because of that there are different approaches how you handle your coordinates, how you handle size of elements, etc, etc. And therefore, even though it looks like a native application inside your platform, actually design how layout for Java graphical applications is designed is actually very similar to web applications. And if you have some experience developing something in web or even web applications, then probably you will not be confused about this, that you need to design layout using different kind of rules. And similarly to your web page or web application, the default layout manager for these internal elements in some container is flow layout, which works in such way that it puts all these elements in next free space starting with top left corner, and then it goes to the right, and then it goes down. And sometimes you may not be happy with this, and then you may use different kind of layout, like grid layout, where you say how many rows and how many columns you will have, and then you can put some element inside particular cell of this grid layout. Then you may have box layout, where you say what kind of box you will have, what is its size, and then some elements either fit or doesn't fit into this fixed box. Then there is border layout, which would be something like for web portals with header, footer, left panel, right panel and content. But for Java applications, these four parts are called north, west, center, east and south. And you can say what is their relative size, each to other. And that's how you can create something with header, footer, panels and the center part. And then there may be other layout managers as well, which are not part of standard Java. And actually in our practical exercise we will use some of such non-standard layout managers. And then when we talk about containers, this main container where everything lives into maybe either G-frame or JApplet, but I will not talk about applets too much because initially this technology was created to compete with Flash, but for different reasons. I think mostly because Microsoft Windows didn't support Java applets well, it didn't took important part of market share. And what is applet? You start with JApplet container, then you have content pane and then you have button, and then you handle them in 5 different methods: init, start, stop, destroy, paint. And it is not a normal Java standalone application, but this application runs inside web browser. And yesterday, when I told you about servlets, servlets are server-side applets on these Java applications, and they are very alive and very popular. And applets were idea to use these client-side applets when you can execute your Java code inside web client, not web server, on other end, and similarly, they respond only to specific methods initiated by events sent from server. You can initialize your applet, you can start, stop it, destroy it, and forcefully redraw screen on some cases. And that would be something like do get, do post, and other methods for this server side or server side applets or servlets. Unfortunately, if you will look, for example, do your browser supports then you will see that your browser doesn't support it anymore in most of cases. And if you check particularly for Firefox, there is Firefox version called Extended Service Release version. That version is only version of Firefox which still supports Java applets. But so this is built on top of Firefox 52, and we have here Firefox 90. So what is here instead? You should know that Adobe Flash fortunately is also quite dead technology. First it was proprietary, and what is used instead? HTML5 with Canvas object is mostly used instead. So that means you mostly use JavaScript and things like that to execute something on client side if you need some kind of graphics. So therefore I will not go into much of details, but interesting thing was that you could create some of Java applications which could be started either as a applet or Java standalone application. Only difference was how you initialize it and how these applications can interact. Particularly for applet, it runs inside virtual machine created by a web browser, so you can't execute anything on local client machine. You can communicate only with server, so send back new data to the server. And previously you could get some kind of warning about this applet. Do you want to run this applet inside browser? But currently you just don't have support for these applets anymore. So now about other Java graphical frameworks which you may hear about and you may be using. So first one, which is not part of standard Java, is called JavaFX. What is very important about it is that it has hardware acceleration for many of these graphical operations, like two-dimensional transformations and three-dimensional transformations, and that is good, because if you write some application in JavaFX framework, then you can actually write any like of computer game with two-dimensional map, three-dimensional map using JavaFX. So that is good. What is not so good is at first it's not open source. You have to agree with license agreements coming from Oracle. And second thing is because it has interface to hardware acceleration to actual physical infrastructure, it is platform dependent. You need to use different JavaFX libraries for Microsoft Windows on PC. You need to have different JavaFX libraries for Linux running on PC. You need to have different JavaFX running on MacOS running on PC, or MacOS running on ARM processors like M1 for very recent MacOS, or very older MacOS running for this previous. So it is platform dependent and not open source. But it is quite popular, particularly to write graphically intensive applications like computer games, simulation applications, etc. So if you do not count that you need to ship it with different JavaFX libraries for a particular platform, of course your application itself is still platform independent. So if you want to create a complicated graphical application, then JavaFX probably is the best framework to use. And another framework which is also not part of standard Java is SWT, and comes from standard widget toolkit, and initially was developed by IBM to design and write Eclipse integrated development environment. And because Eclipse is used as a foundation or basis for many other tools, so this framework is quite popular for different kind of editors, modeling tools, etc. Also, if you use, for example, IBM collaboration server like Lotus Domino server, which is analog to Microsoft Exchange server, then this client, which is called Lotus Notes client, which communicates with Lotus Domino server, is also written in SWT framework. So if you use, and also for example, this modeling tool, IBM Rational System Architect, was also written in SWT. So there are quite a lot of different tools which use, and business applications which use this framework. It is more complicated than Swing, less complicated than JavaFX. And if you need to write some kind of complicated application where Swing looks too primitive for you, then probably this is best framework for your needs. And that's it in short about geographical frameworks. Do you have any questions or comments about it?